Namaskar. Today we are going to discuss public understanding of United Nations Sustainable Development Goal 6, science communication for water and sanitation sustainability. SDG 6 is the sixth Sustainable Development Goal established by the United Nations to ensure availability and sustainable management of water and sanitation for all by 2030. The goal addresses challenges like water scarcity, pollution, and lack of access to clean water and sanitation, which are fundamental for human health, economic development, and environmental sustainability. And key objective of SDG 6 is universal access. Achieve universal and equitable access to safe and affordable drinking water and proper sustainable and hygiene, sanitation and hygiene. Improve water quality, reduce water pollution by eliminating dumping and minimizing the release of hazardous materials, increase efficiency, increase water use efficiency across all sectors and ensure sustainable withdrawals and supply of fresh water. Water resource management. Implement integrated water resource management to at all levels, including through international cooperation and protect ecosystems, protect and restore water-related ecosystems, including mountains, forests, wetland, and rivers. Why SDG matters in India? India houses 18% of global population but has only 4% fresh water. Rapid urbanization, climate change, groundwater depletion, and waterborne diseases is the major challenge. Sanitation linked to dignity, especially for women. And why SDG 6 is priority for science communicators? And the answer is interdisciplinary, high public relevance, and misinformation risk. In the area of interdisciplinary, combines environment, public health, technology, climate science policy, and high public relevance means drinking water, household hygiene. And when we talk about misinformation risk, we have to check carefully about water purity claims, miracles, filtration techniques, filtration gadgets, and misinterpretation of groundwater data. These are all the major challenges in front of science communicators. And understanding SDGs in Indian context, India's water scenario, we must know about this. And over dependence on groundwater. India extracts the highest volume of groundwater in the world, more than China and the US combined. Around 70% of drinking water and 60% of irrigation needs rely on groundwater due to unreliable surface water access. Unsustainable extraction has led to falling water tables, especially in northern and western India. 256 districts identified as water stressed. Government assessment, including Niti Aayog reports, highlight 256 districts facing water stress. These districts experiences low rainfall, poor storage capacity, high demand, and weak water governance. Many are in states like Rajasthan, Karnataka, Maharashtra, Andhra Pradesh, and Tamil Nadu. Population of rivers due to untreated sewage. Pollution of rivers. Nearly 70% of India's surface water is polluted, as per the Water Aid report. Major rivers Ganga, Yamuna, Sabarmati, and Godavari rivers receive large volume of untreated sewage and industrial effluents. Urbanization has outpaced wastewater treatment capacity. Only 37% of sewage generated is treated. Polluted rivers affect ecosystems, agriculture, health, and livelihood. Water conflict regions in India, Kaveri dispute, Karnataka, Tamil Nadu, centered around allocation of river water during drought years and long standing interstate tensions and legal battles. T-Star dispute India, Bangladesh, West Bengal linked to irrigation needs versus ecological flow. Agreement still unresolved due to the monsoon variability and political concerns. Punjab groundwater depletion is another challenge. Over exploitation for paddy cultivation is causing aquifers to drop at alarming rates over 1 meter per year in many blocks, creating a potential future crisis. Major government initiative related to SDG 6. Jal Jeevan Mission, launched in 2019 to provide functional household tap connections. We will discuss about the major government initiative first, then we will come to the science communication aspect of this SDG 6, because first we know the subject part. So, after launching in 2019 to provide functional household tap connection, which is known as FHTCs, and the target of Jal Jeevan Mission is 19 crore rural households to receive clean drinking water by 2024, focus on water quality monitoring and grey water management. And Swachh Bharat Mission is also known as SBM Grameen and SBM Urban. So, SBM Grameen, Swachh Bharat Mission Grameen, means rural areas, focus to rural areas, achieved open defecation free ODF status in 2019, built more than 10 crore rural toilets, emphasis on behavioral changes and sanitary literacy. And SBM Urban, if we talking about cities, focus on 100% waste processing and fecal sludge management. So, this is the Swachh Bharat mission, which is focusing on rural and urban India. Namami Ganga program, integrated mission for rejuvenation of river Ganga and its tributaries, construction and modernization of sewage treatment plants, and focus on river surface cleaning, industrial effluent monitoring, biodiversity conservation, and riverfront development. So, this is all about Namami Gange program. And after this, we have Atal Bhujal Yojana, World Bank assisted program for community led groundwater management, works in overexploited blocks across 7 states, promotes water uh, budgeting, demand side management, and sustainable aquifer recharge. So, this is Atal Bhujal Yojana. And Catch the Rain campaign is another national campaign, nationwide campaign with the theme Catch the Rain Where It Falls, When It Falls. Promotes rainwater harvesting, structures rooftop collection systems, and revival of traditional water bodies. This is utmost important. India has lot of traditional water bodies in our Rajasthan, Gujarat, and other western southern parts of the country, and including our northeast. We have traditional, water harvesting system. Our Baulis, Kua or Coop, and so many kind of arrangements, Talab, famous book Aaj Bhi Khare Hain Talab, written by Anupam Sharma. It is must read for all who are working in any communication or any academics, must read book, and focuses on pre-monsoon preparedness at the district level, because this is utmost important focus on pre-monsoon preparedness, because of our harvesting point of view, farmers point of view, it is utmost important to the focus on pre-monsoon preparedness. So, Amrit mission is another fantastic mission in India, Atal mission for rejuvenation and urban transformation. Focus on improving urban water supply and sewage networks, strengthening municipal water infrastructure, reducing leakages, universal metering, supports storm water drainage, green spaces, and water sensitive urban planning. So, this is Amrit mission. Now, we are going to discuss about the key scientific and technical concept for science communication on SDG 6, water quality parameters. And These are the technical terminology actually include all the definition. So we must understand before approaching science communication to any water or sanitation aspect under SDG 6 or out of the this area. So TDS, total dissolved solids, indicates salinity mineral load. High TDS affects taste, agriculture, and the human or animal health. So TDS is at most important. We will discuss about how much TDS is required in the later slides. pH is the measures acidity, alkalinity, safe drinking water ranges 6.5 to 8.5 pF. Fluoride and arsenic occur naturally in the groundwater. Excessive levels led to fluorosis or arseniocosis. Biological contamination means E. coli signals fecal contamination, key indicator for waterborne diseases. Science reporting angle. Now we will discuss about the science communication aspect of FDG 6. Explain parameters in simple analogies like TDS, total weight of dissolved minerals. Use local water testing datasets in stories, in reporting features, and highlight gaps between the permissible versus actual levels in affected districts. Water purification technologies, reverse osmosis, remove dissolved salts and heavy metals but waste some water, because in any RO system, when it removes the dissolved salts or heavy metals, it wasted water. UV purification kills microorganisms, works best with already clear water. Membrane filtration removes particles and pathogens without electricity. And chlorinification, low cost disinfectant widely used in rural and urban water systems. Science reporting angle, compare technologies based on cost, sustainability, and limitations. Clarify misconceptions like RO is not needed for low TDS water. We have to clarify this misconception. When your TDS is low, RO is not required. You can arrange any simple filter, cheap low cost filter can work with low TDS water. Report on quality assurance and maintenance issues in public water system. This is utmost important because our public water system and its assurance and maintenance is utmost important. Sanitation technologies. Twin pit latrines, low cost, safe and safe rural sanitation model allows composting of fecal matter. Septic tanks, common in urban rural fringe, need regular dislodging to prevent groundwater contamination. Decentralized wastewater treatment, DWATs, useful for small towns, campuses, and peri-urban areas. Science reporting angle, show real stories of how poor maintenance leads to groundwater contamination, track data on fecal sludge management in cities, explain how decentralized system reduce load of municipal STPs. Hydraulic cycle and climate change impact. Very, very important aspect to understand, especially for science communication aspect. Changing monsoon patterns alter recharge rates, river flows, floods, and droughts. Glacial melt affects northern river systems. Extreme water events increasingly affect water security. Science reporting angle on this, use IMD, CWC, and ISRO datasets to show long-term trends. Explain linkages, climate change, rainfall variability, groundwater stress, and drinking water scarcity. Translate technical climate data into everyday impact. This is another good point. So, how you translate technical climate data means dilution without distortion. Yes, please note it down. You have to translate the technical climate data into everyday impact in simple, palatable language without any distortion. You have to explain, yes, with dilution. But careful, no fact is going to be distorted. GIS based water mapping and remote sensing. GIS is used for mapping aquifers, water bodies, flood zones, and pollution hotspots. Remote sensing ISRO satellites help monitor river flow, reservoir levels, land use change, and drought conditions. Science reporting angle use Bhuvan, ISRO search, and India WRIS maps as visual aids in stories. Create local water maps to support data driven journalism. Explain how satellite data validates or how contradicts government claims. Additional concept reporters should know: water budgeting, understanding local water demand versus supply. Non revenue water, it is known as NRW, losses from leakages and theft in urban system. Sewage treatment plant efficiency and BOD COD rating, key indicator of wastewater treatment quality, right? So, we will discuss all these terms here. And science reporting angle is translate technical indicators like BOD, and what is this? Biological oxygen demand, and COD is chemical oxygen demand and its impact on river health. Showcase success or failure of local water management through data stories. And how Indian media cover SDG 6, strength and gaps we are now going to discuss. Increasing coverage due to climate change and environmental activism, there is no doubt. Lot of good coverage, feature writing, reporting, headlines are being made by our media. Rise in climate linked reporting has brought water scarcity, floods and pollution into mainstream news, and major newspapers now run dedicated environment climate desk with specialized reporters. And how Indian media covers SDG 6 strength and gaps. Activism by citizens groups, courts and NGOs created news hooks that keeps SDG 6 issues visual. Data from IMD, CWC, Niti Aayog and ISRO is increasingly used in stories. Investigative stories on groundwater misuse and polluted rivers. Several media outlets upcover illegal groundwater extraction, tanker irregular operations, and commercial misuse. Expose highlight failure of regulation, corruption in water allocation, and health risk from contaminated sources. And river pollution investigations, Yamuna, Ganga, Musi, Sabarmati, other link industries discharge STP failures and municipal neglect. And use of RTI data, yes, and it is very important, and satellite imagery strengthens credibility. Regional media excellence in hyper-local water reporting. Regional and vernacular newspapers closely track village-level water scarcity, hand pump failures, and local reservoir conditions. They report seasonal issues, summer scarcity, monsoon recharge, contamination after floods more consistently than national media. Strong on community stories, traditional water harvesting practices, and local innovations, check dams, farm ponds. Vernacular journalists often have deeper access to communities, making their reports more grounded and solution oriented. Key gaps in Indian media. Now we are going to discuss the gaps in our media. Event based coverage over process based reporting. Media highlight crises, floods, droughts, tanker queues, but rarely follow the long term science behind them, like aquifer depletion, monsoon trends or STP performance. Little continuity in covering follow-up outcomes of government schemes or scientific studies. Very few. We have to take a series of follow-ups and daily routine reporting on government schemes, how the schemes are beneficial for layman and how they can get maximum benefit out of the scheme. And scientific studies, lot of research findings, data is available to be communicated to layman for their knowledge, awareness and information. Weak scientific back-end analysis of water quality. Reporters often quote polluted water without explaining which parameters, right? Pollution कब कैसे और कहाँ क्यों pollution होता है. TDS, BOD, arsenic, E. coli, they are failing to communicate this. Very few stories interpret Central Pollution Control Board (CPCB), Jal Jeevan Mission or state lab reports using scientific context or health impact frameworks. Misreporting occurs when journalists lack access of local water testing data or expert networks. Limited understanding of sanitation, scientific and sewerage management, fecal sludge management, FSM, STP efficiency, DEWATS, DWATS, and sewerage load calculation are rarely explained. Most coverage focus on toilet construction, not on water treatment, leakage, contamination, or safe reuse. The science of nutrient load, pathogen flow, and groundwater contamination is largely missing from mainstream media narratives. Urban bias, and what is rural water innovations underreported. Yes, we are focusing on mega cities, big cities problem, but what are the real problem in our rural areas, in our villages? It was underreported. And metros dominate headlines. While rural innovation check dams, johars, farm ponds, traditional recharge wells get limited space, and they have utmost potential to be highlighted and to be adopted in our cities, in our urban areas. Lack of field reporting reduces visibility for community-led models, women-led water committees, or tribal water governance practices. Rural data scarcity and logistical challenges worsen than imbalance. In insufficient data-driven journalism. Few stories are GIS maps, satellite imagery, long-term rainfall data or groundwater trends from CGWB. Visualization of water quality, STP, capacity gaps or river pollution loads are rare compared to global media standards. Data exists but is underused due to low training in environmental data literacy. And common myth and misinformation science journalism perspective, we talk about misleading claims by water purity campaigns. Companies often, exaggerated threats like all water is unsafe to promote RO system. Science reporters must clarify when RO is needed in case of high TDS and when simple filtration, chlorination is enough. Many ads ignore the fact that unnecessary RO use waste large amount of water. A key sustainability angle of SDG 6 stories. So in this lecture, this is all about the reporting aspect of water and sanitation in as far as SDG 6 are concerned. So next time we will meet again and we'll follow this discussion. Thank you. Namaskar.